Good morning and good evening to everyone who's joining us for today's discussion on Where's the Water in the Mekong Dry Season 2023. I am going to hold tight for a minute, and hopefully all of you will be willing to sit tight for a minute while everyone joins from the waiting room. I think we're getting a lot of people trickling in right now, so we'll get started in just a minute. And in the meantime, I am going to share just a very brief logistical note. As many of you probably saw in the RSVP form, we do have live translation available tonight. So before we get into the meat of things, if you want to hear in any of the local languages instead of English, all you need to do is look at the bottom of the screen for the interpretation button with the globe, and it will give you your choice of listening in any of the 6 local languages: Burmese, Chinese, Thai, Lao, Khmer, and Vietnamese. So please feel free to shift into the local translation channel if any of you in the audience feel more comfortable listening in your local language. I will also note today's discussion is intended to be very interactive. We're going to have some really interesting explorations of data and what the data means from our presenters tonight, and then comments from our discussants, and then we are going to shift into hopefully a half hour or so of Q&A with the audience. So throughout tonight's discussion, if you have questions coming up on any of the data, please feel free at any time to drop your questions or your comments into the Q&A box at the bottom of the screen. And when we get to the discussion portion of tonight's event, then I will be pulling from that, and we can certainly go back to follow up on or clarify any questions you had about the data presentations as they were occurring earlier in today's session. So with that said, I think we're still getting people coming into the waiting room, but the rate has slowed down. So in the interest of time, I am going to go ahead and just sort of run through our brief intro for tonight's discussion and then turn things over to our data experts to really tell you what's going on in the Mekong. So thank you everyone for joining. As many of you know, this is the 3rd in our series of seasonal updates that the team that runs the Mekong Dam Monitor provides to give an overview of what's going on in the Mekong in recent months and what to expect in the forthcoming dry season. My name, for those who haven't met me before, is Courtney Weatherby. I'm the Deputy Director of the Southeast Asia Program at the Stimson Center, and I will be acting as the moderator for tonight's discussion. So as many of you know, in 2022, the Mekong experienced the first normal wet season in 4 years. And the benefits of that are currently seen and still flowing as we move into the dry season in the form of higher than usual levels of water and all of the benefits that those floodwaters provided. However, upstream dams are already releasing water for hydropower production starting this month in January, which is artificially raising the river level and has implications for how much water will be available and how water will flow in coming months. So tonight's discussion is really a deep dive into the data from the Mekong Dam Monitor. And we do welcome all of you to explore the major findings from the 2022 wet season and the forecasting for 2023 dry season throughout the discussion. I do want to recognize that data is very complicated, and the goal of our presentations for tonight and the discussion for tonight is to really present a clear message on that complexity to you in a way that tells a story about what's happened in the Mekong and what's likely to happen this coming dry season. So as I said, if you get confused about any of the data or have questions and want to dig into things at any point, please do feel free to say so in the Q&A box, and we will return to that later on in the discussion. So with that said, I am going to turn things over to our presenters for tonight, who are really going to give you that deep dive in the exploration of the data. So we're going to start out with presentation from Brian Eiler, who's the director of the Southeast Asia program at the Stimson Center and the co-lead on the Mekong Dam Monitor, as well as Alan Basiste, who's the president of Eyes on Earth and the co-lead of the Mekong Dam Monitor. So Brian, Alan, I'll turn things over to you for the deep dive.
All right, I'm just going to share screens and Alan's going to get us started. Thank you, Courtney.
And I want to thank Courtney as well. She's done a wonderful job of introducing the work that we're doing. The goal is, as she said, is to tell the story, to communicate through lots of different data, a very simple message: what is happening in the Mekong Basin and how we're able to monitor and what does it mean. So we'll start moving right into what's happening with the dry season. And before we do that, we have to start with the wet season. So we'll start in June of 2022, which is pretty much near the beginning of the wet season. Now, what you're looking at right now are a series of 8 different maps of the same region. It's the Mekong Basin, all the way from the very north, which is the Tibetan Plateau, down to the Delta in Vietnam. A simple description of what all these colors mean. The darker and darker shades of red mean it's drier than normal. In fact, the darker the red, the more the drier it is relative to the 30-year average wetness at that location for that month of the year. And equally, on the other side, is darker and darker shades of blue, all the way to purple. And so those darker shades of blue mean that it's wetter and wetter than average in those locations at that month of the year. So with that description, let's go to look at June and see what's going on. We can see that there's a dryness in the gorge area coming down, and then we see a lot of wet anomalies as you're heading into Northeast Thailand, into Cambodia, and down to the Delta. It's extremely wet, with purple, which means much wetter than average for that time of the year. So we're seeing a lot of wetness early in the season in the lower basin and a lot of dryness in the upper basin. If we move into July, the next image on the top left, then you can see that there's a lot of dryness throughout the basin. In fact, most of the basin is unseasonably dry for July. So the wet season got off with a bang in the lower basin, and in July, things started to dry out tremendously relative to the beginning of the wet season. And then August was even more pronounced dryness. So you can see some wetness down in the Cambodia area and down into the Delta. But outside of that, you can see that in Laos and in Northeast Thailand, there's a tremendous amount of wetness. And you can see that there was a drought. I should go back in July. There was a huge drought up in the headwaters in the upper basin in the Tibetan Plateau. But things started to shift a little bit as we went into September. So we're on the top left now, and you can see that all those dry anomalies are certainly abated. But Brian is taking us to the next image, because before we get into September, we wanted to show you that what we're seeing in the Mekong is not necessarily the only thing we can see. We can see throughout the world. So these satellite observations are basically global in their ability to observe what's happening in the world. And an example of that, there was a major event in extreme wetness coming into into Pakistan. You can see that area that's circled. Those are extreme anomalies, but equally is those extreme dry anomalies in the Ganges River Valley. So in meteorology, we call that a dipole, and all into the Eastern Tibetan Plateau. So what happened was that the monsoon, which normally goes up the Ganges River Valley and feeds northern India with a tremendous moisture feed and into the Tibetan Plateau, was completely deficit. And most of the rains, the monsoonal rains, came in out of the Arabian Sea directly into Pakistan and cut off the moisture supply that would normally come into India and to Tibet. And that's pretty typical, is that one area gets the rain at the cost of the other. So we're seeing the relationship around the world of areas that are getting abnormally wet conditions, and conversely areas that are exceedingly dry relative to basically what they would expect at that time of the year. So now let's go back to the other image so that we can move on with it. Oh, I think we're supposed to go back to, there we go. So now we can go back to September, and you can see that there's some wet anomalies down in severe wet anomalies down into Western Cambodia. And that was feeding the Tonle Sap Basin with a phenomenal feed of moisture into the basin, which was raising the lake levels, even though you can see that dry anomalies are to the north in coming out of Lao and much of the upper basin and middle basin. But though the Tonle Sap Lake itself is rising rapidly, not from a reversal, but from the excess rains in and around the basin that surrounds the Tonle Sap Lake. If we go into early October, you can see that there was a huge pulse of water in the Tibetan Plateau, much above average wetness there. But also you can see that those extreme wet anomalies that are down around the Tonle Sap Lake are continuing to dominate the area. In fact, in November, they're even more dominant. In December, they persist again. And so those extremely wet conditions in Cambodia feeding the Tonle Sap Lake have kept it at unusually high levels, not from a reversal from the Mekong, but from the rains in and around the basin itself. So we can see then, we want to go one last image and then we're going to move on. We're going to go to early January, which is on the bottom right. You can see that they're starting to get extreme wetness in the Tibetan Plateau, both in December and January. Temperatures are warmer than average. What is normally snow covered is actually wet now, which is related to climate variability, climate change. We're seeing unusually wet conditions and less persistent snow cover in the Tibetan Plateau in these last 2 months. So let's move right along. And we'll move to the next slide.
My computer is going slowly tonight. It must
That's
be
okay.
affected by the unique climate pattern of 2022.
Well, it gives me a chance to catch my breath a little bit before we move into a new image.
Sorry, it's just not advancing.
Yeah, well, while they're doing that, yeah, we have to go one more.
There we go.
Perfect. And so what you can see here, this is actually the wetness anomaly also that we able to monitor how wet the surface is with satellite observations. And we can see the surface under all sky conditions. So this is another source of kind of collaborating evidence to understand what's going on. And you can see that in late July, there was an expansion around, you can see the expansion around the Tonle Sap Lake. You can see that green values, the lake is expanding, and you can see that the wetness is expanding down into the Delta region of Vietnam. You can see in that expansion contracted a little bit, which is unusual in late July and early August. Which had been more of an expansion in late July is now receding a little bit. The anomalies are weaker, or not the anomalies, the wetness patterns are weaker, and the area is kind of contracted a little bit. So we're seeing a contraction. And then in August 7th to the 13th, you can see that it continued to contract. So what would have normally been an expansion of wetness throughout the lower basin and into the Delta is actually a contraction. And then you can see that in late August 14th to 20th, you can see that it's starting to expand out again. So this is what we call a accordion effect, that things do not in nature, things don't happen in natural, systematic, linear, continuous fashions. Nature's far more interesting, far more erratic. And you can see some of that erratic nature in that the wetness patterns and the expansion contracted and then expanded again in late August. And that's what we wanted to be able to show you here. And we can see it in another image as well. We can see, now this is using a different satellite observation. This is using SAR, and it's actually identifying water on the surface. It's not identifying wetness, which was the other product. The other product was really kind of soil moisture, but this is actually water pooled on the surface. And so we have a couple of colors here. We have the blue, which are areas that the satellite has identified as inundated. Its water is on the surface. Of course, the lake stands out as prominent. And then you can see that the green color, which we'll get more into, is areas that would normally be flooded that are not flooded. And we have a average condition going back 100 years. So we know what should have normally be flooded over that 100-year record, what's average, what's expected. And so we're going to look and see how that changes. So if we look into June, we can see that there's really not a lot of areas that are inundated, but it's more than July. So this, again, is another source of information that is kind of telling us the same story, that there was a lot of wetness in July in the lower basin, and it contracted, in June, and then it contracted in July. And so there's less areas that are inundated in July. And in August, you can see a lot of green. Now that green is areas that are along the main stem of the Mekong, which Brian may circle here in a second. This computer's cooperating. And then you can see all that areas that should be, on average, already flooded, already covered with water, but it's not. So the inundation, which we would expect at this time of year, is really kind of, I guess, retarded a bit. It kind of kept back. It's not nearly as pronounced as it should be on average. And then we can see in September, we can start to see that a lot of green still, but we're starting to see blue fleshing in again. So we start seeing flooding conditions in September, early September, but still a lot of green, which means a lot of areas that should normally be inundated in early September are not. So the flood pulse is really quite depressed, but that changes in October. You can see all that blue area. And we saw that in all those wetness anomalies too, that the Tonle Sap Basin was just being inundated with rainfall, particularly to the south and west of the basin. And that all that moisture is coming into the basin and then flowing into the lower basin, into the delta region of Vietnam. As you can see that there's very little green there. So basically places that are normally covered with water are covered. If you move to November, things are starting to turn, a little bit of green's coming back, but look where the green is. The green is in the main stem of the Mekong. It's not in the Tonle Sap Basin. So the Mekong is actually lower than normal and is having less flood inundation, while the area around the Tonle Sap Lake is up high. The basin is flush with water, not from the Mekong, but from its own basin. And that is actually all that excess water is getting into the lower basin, into the delta region. So the flooding in the delta is mostly coming, or at least a good portion of it, is coming from the Tonle Sap Lake and not the main stem. And then you start seeing things as one would expect. You start seeing things cutting back in November. It's the end, kind of the end of the wet season, and you're starting seeing that a lot of that water is now flushing out of the lower basin. And you can see in early January, you can see it even more pronounced. The lake is basically shrinking, and a lot of that flood pulse is actually already moved off the coast, and the water is receding from the land. So we'll move on to yet a very different plot, but it's telling us kind of the same story. This is some research that we've done recently, and I'm not going to be able to go into the research much right now at all, but I can introduce some of the findings. What we studied is how much water is coming out of the Tonle Sap Basin and how much water is coming into the Tonle Sap Basin from the reversal of the Mekong. So one is water from the basin itself and flowing past the Prek Kadam gauge. And the other is water coming from the Mekong, reversing up the Tonle Sap River. So the gray is
Alan,
the
can you
reversal.
clarify where the Prek Kadam gauge is and why we've chosen that?
Sure, that's a good question. The Prek Kadam gauge is about 100 kilometers, not even that far, I don't believe, but it's a little ways up from the intersection with the Mekong main stem. So if you go from Phnom Penh, where the Tonle Sap River joins the main stem of the Mekong, you go up that quite a few meters, but still not too far from the intersection with the main stem. There's the Prek Kadam gauge. And so it's really measuring the movement of water both into the lake from the main stem. When the river's high, when the main stem of the Mekong is high, it's higher than the lake. Water always goes downhill. So if the river is higher, then the water is going to go up the Tonle Sap River past the Pret Kadam gauge and flood into the Tonle Sap Lake. And that's what all this gray is. All this gray over the time series are the pulses of water from the reversal from the Mekong. And you can see that there's a kind of an annual cycle, that there's a pulse of water coming in from the Mekong during the wet season. And then you see during the dry season an outflow of water. So all the gray are these pulses of reversal coming in. And then you can see the black are the excess water coming into the Mekong River from the Tonle Sap Basin. So it's just the opposite of reversal. It's actually water coming in from the Tonle Sap Basin flowing out towards the Mekong River. And you can see somewhere around, so around 2007, 2008, things shifted fairly radically. The amount of water coming in from the Mekong is less pronounced. The peaks are are lower, and the period of reversal for the Mekong is certainly shorter lived and less pronounced. But equally, and probably more importantly, the black is the extra water coming out of the Tonle Sap Basin towards the Mekong. And so you're seeing that more and more of the water in the Tonle Sap Lake is originating from the lake and flowing out towards the Mekong, and less water is coming in from the reversal of the Mekong during the wet season. So this means really two things. There's less water coming into the lake from the Mekong, so less nutrients, less reverse flow, but also that more and more of the water in the Tonle Sap Lake is actually originating from the basin surrounding the lake and not from the Mekong itself. And a lot of that water is flowing out in towards the Mekong, whereas normally there was less flow. This is going to highlight what happened in the most recent year. And I think this is a really good example of what we're seeing. The blue line is basically the model predicted flow, what would be at the Pret Kadam gauge. And the brown line, or the orange line, as you may say it, is the actual gauge measurements. So you can see that there was, and down below, black means that there's water coming out of the basin towards the Mekong River. So it's coming out of the Tonle Sap Basin. The gray, and you almost see none of it, means that there's a reverse flow. And that's the point. There's almost no reverse flow in 2022. Almost all the water that filled the Tonle Sap Lake this year came from the basin itself. And so we always looking for collaborating evidence to see that our data is correct or where there's biases. And a really good source of collaborating evidence is some data that's collected from the Mekong River Commission. The black line over on the right is kind of the mean reverse flow, how much water comes into the Tonle Sap Basin. The dot blue line is the maximum reverse flow, and the bottom blue line over the mean period 1996 to 2005, you can see that the mean average for that is 10 years. The blue line is the minimum flow. Well, look at 2022, it's the red line, it's below the minimum. So there was almost no reverse flow according to the MRC, nominal reverse flow from the Mekong into the Tonle Sap Lake, which supports the findings that we see over on the left. So most of the water in the lake is actually originating from the basin and not from the reversal. So I know in being attentive of time, I should keep on going. So I'm gonna think is that my last slide, Brian?
That's it.
All right, well, good.
Yeah, and I think a lot of our findings today, thank you, Alan, they kind of challenge conventional wisdom that the reversal is the main driver of the expansion of the Tonle Sap Lake and is a key driver of the health of the Tonle Sap Lake. What we're finding now is that the reversal, for better or for worse, is mattering less and less. And water coming from the Tonle Sap watershed and what other things come in that water are becoming more and more important. So I think that's an important message for conservation of the Tonle Sap watershed itself, and also just a strong signal that the water that should be coming down the mainstream during the wet season just isn't. And part of that is due to drought. And then part of that is due to dam impacts. So what I'm going to do is go over dam impacts. I'm going to go over this very quickly so we can get to our discussion section. That upstream drought that Alan talked about caused lower storage levels than 2021 and in previous years. So storage levels in reservoirs come when they take water from wet season flow, when dams recharge their reservoirs and fill them up. And it happens during the wet season. And particularly in China, in the upstream, in the upper Mekong, there was a drought, as Alan showed. So the two largest dams didn't fill as much. Last year, storage peaked at 84% total capacity. That's the amount of restrictions that came from the Mekong. This year, it peaked at 74%. So it was about 10 percentage points lower. And importantly, currently, the amount of active storage or usable water, as we call it in China, is 47% lower than what it was at this time last year. So there's a lot less water in those dams. And we can see that through our virtual gauge process. Just looking at the two largest dams in China, and again, these dams hold 50% of that usable water in the Mekong, or active storage in the Mekong. They didn't drain as much as they typically do during the dry season last year. Perhaps there wasn't as much electricity needed for various reasons, China's economic slowdown or pandemic response. And that drought that we observed didn't allow them to fill as much as they did. Now, they could have, but they didn't. So kind of what we're saying is they could have taken more, but they didn't. And that's something that's interesting to us. And they've already started to release. Norjiadu, particularly the largest dam in the basin, it typically begins to release water for hydropower production in March of every year. But if you look, you see it started releasing in October. So that's like 5 months early. We're not sure why that's happening, but it's happening. And this is something to pay attention to because it has implications for how this next dry season, this coming dry season, or we're in the dry season now, how dam releases will impact flow to the downstream. But just going back to the wet season, we saw a very typical pattern coming out of the upper Mekong, that dam releases during the dry season raised the river level, and then restrictions during the wet season reduced the river level. We believe this is very damaging for ecological processes, for fisheries, for wetlands, for communities in the Mekong, and most of our literature talks about why that's very damaging. But we saw this happen, kind of a typical pattern of dry season releases and wet season restrictions. Let's see how that impacted. Now, remember that wet season flow in China was less than usual, and there were fewer restrictions in those upstream dams during the wet season. So actual flow to Changsan, Thailand was a little bit higher than 2020. Restrictions were a little bit less than previous years. So the amount of restriction, the amount that those dams restricted flow was less than previous years. So in 2020, just the two largest dams alone reduced flow to Changsan, Thailand by 73%. Now, all the dams in 2022 in China reduced flow by about 19%. Now, that's still a significant flow reduction, but it's much less than what was previously observed. If we move this down 1,000 kilometers downstream to Stung Treng in Cambodia, Changsan kind of being the most upstream area of observation, Stung Treng being the most downstream area of observation, we see a similar effect that in 2020 alone, those two largest dams in China reduced total wet season flow to Stung Treng by 8.5%. That's a lot, right? That's not a small number. This year, still 6+%, but interestingly, the lower Mekong dams restricted more flow than the upper Mekong dams in China. combined, they still reduced flow by 6%, but it was the lower Mekong dams that did the most. Now, this might be complicated. I just want to run through some points. We're tracking month by month impacts of upstream dams, upper Mekong dams and lower Mekong dams. September 2021, we've discovered that upstream dams reduced total flow to Stung Treng by 20%. That's a lot. So the numbers I showed just previously were seasonal. That's a seasonal average, wet season average. This is per month, 20% flow reduction to Stung Treng by upstream dams in September 2021. Moving into the the dry season in 2022, on average, per month, dam releases increased flow by 35%. Okay, that's significant. And we're going to take a deeper dive into this as well on the next slide. And then moving back into the current wet season, average dam restrictions reduced flow by 7%. Now, that's a little bit less than before. We've already talked about why that's happened. It's related to that drought. Just looking at the dry season of 2022, again, monthly average was 35% flow increase. So dams increase flow. Dams release water during the dry season to produce hydropower, and that's artificially raising the level of river. We've invited some discussants to talk about what that's doing to the ecology of the Mekong, to the fisheries, to the fauna, to the biodiversity of the Mekong. The answer is shortly, it's not good. You're going to see more details in a bit. But March 2022, dam releases upstream, combined of upper Mekong Dam impacts in China and lower Mekong Dam impacts, increased flow by 107% to Stung Treng, Cambodia. That's huge. And that's causing some major damage. And we're going to look into that more deeply here in a second. Just want to point out, my final slide is that we're providing a very, I think, critical service to the people of the Mekong of when these major dam releases or restrictions are happening. So in 2022 alone, we issued a number of early warning alerts. The most early warning alerts that give people and communities in the Mekong 2 to 5 days to adapt to these changes. The highest category of alerts that we issued were changes of releases of water greater than 1 meter in 2022. And the largest we tracked was 1.6 meters that moved all the way from the Chinese border down to Chiang Khon and close to Vientiane, Laos. 1.6 meters caused some major flash flooding right around the time of Thai Lao New Year. And this was in the news. It caused some damage along the lakes, along the riverside, particularly to those people who were celebrating New Year's along the riverside. So we're going to be watching these releases. Again, we issue our alerts 2 to 5 days before their impacts, giving people time to prepare. But these dry season releases are coming. We think there will be less in terms of total volume than previous years because there's just less water in reservoirs, yet they're still going to come. So I'm going to end my presentation there and call on Regan Kwan just to give a very brief overview of what's to come for 2023 for the Mekong Dam Monitor.
Thanks, Brian. I'm going to quickly share. So yeah, just as Brian noted, we have a couple of new features for the Mekong Dam Monitor as we enter the 3rd year, as well as some updates to existing features. First off, I'll just go with our newest or update, sorry, of what we currently have. We're first going to release a new version of the Langkang Cascade, which used to be and still is a chart on the Mekong Dam Monitor. We're now going to make that into a map. As you currently see, there's a rough draft of what we have. It's going to give you a great explanation of what's currently happening above the Mekong in China by dam, as well as the entire upper basin. As you can see, just last week, there was a release of a little under 360 million cubic meters of water. In addition to that update, we also have 2 new features that we're going to add in later this year. From funding from Wonders of the Mekong, we're going to release 11 new dams from the 3S basin. So this is the Sri Pak, the Sisan, and the Mekong. This is based off in Cambodia, Laos, and Vietnam. In addition to that, we're also going to release a new natural flow model from the Mekong from work by Alan and his team at the Eyes on Earth. That's just a quick update. Hope everyone enjoys the new products. Thank you.
Yes, thank you for that, Reagan. I know it's always exciting to see the data expanding because it allows us to get much more nuance with the type of analysis that we do. So that is wrapping up the presentation of the data and what's coming from the Mekong Dam Monitor this year. And at this point, we're going to turn to our discussants. So we're going to kick things off with some commentary from Andy Ball, who's a Cambodia-based photographer and videographer with an interest in covering stories that revolve around the cross-section between society and the environment. And Andy is going to show us some really great on-the-ground images from his work showing what's going on to correlate to this data. So Andy, over to you.
Thanks, Courtney. So I'm just going to share my screen real quick. So I've got photos from the story. So just checking, can everyone see that? That's good.
Yeah, it's coming through.
Okay, great. So I'm going to talk about the Stung Treng flooded forest. So we did this story for the third poll with my colleagues Marta and Buddha. And I did actually, just before I start, I just want to say that a lot of the research that was used in the story came from Professor Ian Baird from the University of Wisconsin-Madison. So he's worked a lot on this in this particular area, the Mekong. He actually lived here, and he's worked researching this issue directly. So thanks, Ian, for sharing his research with us for this story. So just as a bit of context, a lot of this builds on these kind of ecological impacts of the dry season releases that Brian's been talking about. So this is the Stung Treng Ramsar site. It goes from the Laos-Cambodia border down to this kind of town of Stung Treng in Cambodia. It's a beautiful ecosystem and really unique. There's a number of bird and fish species that have been recorded at the site, including things like critically endangered white-shouldered ibis. But what really makes this site truly unique, and it is unique on the section of the Mekong, is the tree species. So these really large acacia trees with their strangler figs. If anyone goes to the site, they're very iconic looking trees, and they make up this beautiful ecosystem and complex that makes the site very, very unique. So these trees are really important. They provide a habitat for a number of fish species as nursery and spawning grounds. But what's really interesting, and this is again from Ian's research, a number of these fish species from cyprinid carps and Bagantidae catfish, they're actually eating the flooded forest fruits and leaves. So it's also providing a food source for a lot of species. So on the right is a picture of the cyprinid carps that fishermen had caught at the site. And on the left, some of the fishermen are actually using the flooded forest fruits as bait, which I think it really illustrates this kind of relationship between the forest and the fish quite beautifully, I think. So yeah, they do that at certain times of the year. And all of the communities we spoke to at the Ramsar site, they're saying the same thing. So 20, 30 years ago, the water levels during the peak of the dry season were a lot lower. They're actually telling us how they could walk across sections of the Mekong, but now they can't walk across those sections. They're completely flooded, and as a result, these trees are remaining wet all year round when they should be going through these annual cycles of drying out and flooding at various times of the year. So as a result, a lot of these trees are dying. So these are the kind of gnarled up remains of the bushes and trees at the site. If you go to the site, you'll see almost these graveyards of hundreds of trees. So here's a drone image for perspective. So you can literally see these trees have either fallen over or just kind of left with their kind of corpses at the side of the river. And it's happening all over sections of the river. The locals are talking about huge changes in the forest over the last 20 or 30 years, last 5 or 10 years actually in particular. And here's a good example of one of these acacia trees, which actually collapsed under its own weight after dying. You can see the strangler figs at the bottom. And this was probably just, a few months before we arrived at the site late last year. And obviously this death of the forest is, going to have huge implications for the ecology of the Mekong in general as well. A number of species using this as nursery and spawning habitats, as well as a food source. The actual extent to which that will impact Mekong fisheries, I don't understand, has actually been looked into, but obviously it will have implications for that. But also the locals living in the area, they're being impacted by the loss of this forest. So this is Sai Fang, a village chief, and he was saying that with the loss of the forests and also the loss of the recent dolphin population up there last year, the Irrawaddy dolphins, tourism prospects are not looking good at the site. As the forest has started to die, the fisheries are also, just not as reliable for income. So a lot of youth are turning to migration for work. So his two granddaughters had gone to Thailand without passports in search of work because fishing is just no longer a viable option for a lot of the community. So just to bring in that kind of local context as well as regional context for the story. I think that's I think I went through that quite fast, but that's kind of the overview of the story. I think I put a link to the story in the third poll somewhere. We're working on getting it translated into Khmer as well, so I can send that over when that's done. Okay, thanks a lot. I think Ellie is after, right?
Indeed. Thank you so much for that, Andy. And I will drop the link into the chat shortly so that people can access the article. And so with that, I think we're going to turn over to Elizabeth Everest, who's a graduate research assistant and supports the USAID Wonders of the Mekong at the University of Nevada, Reno. It can also share some on the ground visuals and expertise on fisheries. So Ellie, over to you.
Yeah, thank you guys so much for joining us all today. And it's been an awesome presentation so far, really interesting to see how things are being perceived on different levels. So we at the Wonders of the Mekong project, which I'm conducting research for, do kind of focus more on the fisheries side of what's going on in the Mekong. And our project works primarily in Cambodia because despite the kind of upstream developments that are going on, we do see some really positive events here in the Mekong and the Tonle Sap in Cambodia itself. So the river is healthy in a lot of ways here in Cambodia. Over the last year and a half, we've had some amazing discoveries in this region. So one of the world's largest freshwater fish, the giant Mekong stingray, was captured and released. And we have research going on. We're able to kind of see where these animals are moving in the system, and they're still present. There was also the rediscovery of a fish that we had thought to be extinct, the giant salmon carp, just in the last year. There's runs of an historically threatened species that used to be abundant. We're seeing more numbers of the threatened Laotian shad over the last few months and into last year. And this is critical habitat, as Andy was saying. The incredible Stung Treng Ramsar site that he was showing us pictures of is key habitat for these species over the course of the dry season. So we are hoping to continue research on this area. So there's some really incredible things that are going on in relation to fisheries in this area. One of the kind of main connections between fish and flow that people use as an indicator of how the fishery is doing historically is the Dai fishery that's north of Phnom Penh on the Tonle Sap River. And this year in the Dai fishery, we're seeing a lot more large species than we have in previous years. So Dai fishers and the people on these platforms in the middle of the river have been reaching out to us and contacting us and releasing some of these large endangered fish, which has been really incredible to see. Just this morning, we received a phone call that they've caught and will be releasing a 10-kilo giant barb, which is the national fish of Cambodia. And so they're still seeing these species in their nets, which just goes to highlight that these species are present here in ways that they might not be in other places. So this is a refuge for some of these iconic fish that we want to be able to continue seeing in the future. So we really have a focus on trying to help Cambodia maintain the health of its rivers and the connection that we're seeing between the Mekong and Tonle Sap watersheds. And if we are able to kind of encourage sustainable development in Cambodia, there's a refuge for a lot of these really incredible species that we're still seeing present in the river. So we can focus on maintaining kind of the connections that we're seeing here in country, despite some of the other changes that are going on upriver. So that's our focus, and we're hoping in the near future to be putting in potentially a research station in Stung Treng and some of these key habitat areas where we want to understand more what's going on with the fisheries and changes in flow. So thank you so much, and I'm really looking forward to your questions.
Thank you for that, Ellie. And I see we've got at least 1 or 2 questions on fisheries already that I think I'll be able to direct to you when we get to the discussion. So next, we're going to get some comments from Ming-Li Yong, who is a fellow with the East-West Center and who spent many years on the ground in Cambodia and has great expertise on the Mekong. So Ming-Li, I'm happy to turn things over to you.
Thanks, Courtney, and thanks everyone for the really great discussion so far. So I'm going to speak a bit more about the complexities of these issues for communities on the ground, especially with the focus on the Tonle Sap Lake. So I'll be making 2 points around livelihoods and conservation. So the fisheries of the Tonle Sap Lake and its floodplains are really important. It provides about 60% of Cambodia's protein intake, which is a really high percentage. The Tonle Sap Lake also supports about 1.7 million livelihoods that are dependent on its natural resources. So this includes its fish and its flooded forests. I was going to share some pictures. Hang on. All right, here we go. All right, so this is a picture from Tonle Sap Lake. But at the same time, there's really no doubt that making a living on the lake is getting more and more difficult, especially for people who fish for a living. This is really due to a long history of post-conflict dynamics, weak governance, large-scale commercial fishing, and more recently, of course, hydropower dam development and climate change as well. So fishers are generally struggling to make ends meet, especially with declines in their fish catch. So more people are catching less fish than before. They have to travel even further away from their homes to catch fish, to access new fishing grounds, or they have to leave their fishing livelihoods completely. So this involves going to wage labor, for example, migrating into the construction sector in urban centers. So this is really especially an issue for people who don't have access to land, the people who are living on the water in the lake. Those who have land are luckier, so they can engage in other livelihoods such as farming. But one of the implications of not having enough fish is that these small-scale fishers also then have to resort to using illegal fishing methods. So, for example, using nets with smaller mesh sizes to sustain their livelihoods and sustenance. So the rationale is, if everyone else is doing it, they lose out if they don't engage in illegal fishing as well. But of course, this then creates a negative feedback loop that further depletes Tonle Sap fishery. But I just want to say it's not just small-scale fishers are not just a problem. There are also commercial fishers that use such very problematic methods. So on a broader scale, these sort of issues are also tied to worrying problems around high levels of indebtedness in Cambodia, which again, in turn, are tied to migration for work into very precarious forms of work, such as in the brick kilns. But because the health of the fish populations are so closely tied to the ecosystems of the Tonle Sap Lake, it's really necessary to consider the linkages between livelihoods and conservation as well. This is a really complex issue, I think. So there's a really close connection between water, flooded forests, and fish. This is such a unique ecosystem that's tied together by the flood pulse of the Mekong and the reversal of the Tonle Sap River. So it's really interesting, I think, to think through the implications of these findings that are being discussed here. And all these are necessary for the fisheries to stay healthy. The flooded forests are seasonally flooded. And they're also coming under threat. There's, deforestation going on as land is being cleared. Forests are being cleared for land. The 2016 large forest fires in Prek Do also come to mind. And in the past 2 years, the Prime Minister of Cambodia has actually heavily criticized the failure of provincial officials to address issues of illegal fishing and the logging of flooded forests. And this has led to a quite severe crackdown on illegal fishing and farming in the zone that is closest to the lake, where these activities are officially banned. However, these people have been, doing fishing and farming in these areas, sometimes for decades, where the rules have not been enforced. So having to suddenly not have access to these livelihoods due to these crackdowns is also a key concern. So I think while the conservation of these critical ecosystems is necessary, of course, to sustain a healthy natural resource base for the Tonle Sap Lake, I think the question then is, what forms of conservation or governance arrangements can also support local livelihoods? What kind of support can be provided to communities to transition into, less precarious livelihoods? I don't think we should be moving towards, fortress models of conservation where we're trying to keep people out of the lake completely, that then penalize small-scale fishers trying to make a living and trying to feed their families. Also, fishing on the lake has been going on for centuries in Cambodia, and its economic and cultural significance really cannot be understated. So I think, there has been some efforts to rezone the lake to accommodate households who have been farming in those areas for more than 10 years. But I think the effectiveness of these measures we'll have to monitor closely, given longstanding issues of weak governance, rule of law, and corruption in Cambodia. And just quickly, I think in relation to hydropower, I think we need to consider Cambodia's plans for hydropower development. While it cannot control hydropower development outside of its country boundaries, I think they can think about hydropower development within the country. So I think at the moment, it's that there are rumors about the revival of the Slim Dam that will issues. So that's all I have for now. I'm looking forward to discussing these issues more. Thank you.
Thank you, Ming Lee. And last but certainly not least, we're going to have some final discussion from Dr. Duan Van Dien, who's a full-time lecturer at the Vietnamese German University in Vietnam, and who specializes in water resources, engineering, management, hydraulics, and sediment. So Bien, over to you to close things out.
Yeah, thank you very much, Courtney. So good morning, everyone from Vietnam. So I am Bình from Vietnamese German University. Today, I would like to introduce you about the effects or the relationship between discharge and water level in the dry season in the Vietnamese Mekong Delta. And why I say so, because usually when the water discharge increases, the water level will increase as well. However, I will tell you a very different story in the Vietnamese Mekong Delta when we incorporate the morphology in the delta also. And here you see in these two figures on the bottom, the discharge in dry season at Tân Châu and Cần Mỹ Thuận station. You see the location here. They are locating in the Tiền River, which is the Vietnamese name of the Mekong River. So you see the dry season discharge at these two stations are increasing, and over very long time periods from 1980 to 2016. However, when we look at the dry season, long-term dry season water level in these two stations, you see the left one at Tân Châu station, using here the low flow season and the minimum water level. You see the decreasing trends we can observe. Similarly, at Mỹ Thuận station also, the low flow season and the minimum water level are decreasing over time from 1980 to 2016. And actually, the low flow water level, I make the average value of 3 months for the minimum flow around the minimum water level. And you see, really, they are really different or paradox. Normally, we know when the dry season water level increases, or the dry season discharge increases, the dry season water level will increase. But this one, we cannot see like that as a natural river. So then we look at the morphology of the Mekong, and we see that the riverbed elevation has been decreased so much. And you see here we compare the riverbed elevation in 2 periods. The first one from 1998 to 2014. We calculated the mean in-season volume and we found that the in-season volume about 16.7 million cubic meter per year, or corresponding to about 16 centimeters per year. However, recently from 2014 to 2017, the in-season volume of the riverbed increased up to about 3 times, up to 52.5 million cubic meters per year, equivalent to 50 centimeters per year. Or we can say that riverbed of the Mekong Delta now is decreasing because of maybe because of sediment reduction. Here I will show you in this last slide the sediment reduction in the Mekong. I plotted I compare the sediment loss between two periods, 2012 to 2015 compared to before 1992. As you know, before 1992, the Mekong River was pristine or natural state. So we see along 6 stations here at Shenzhen, sediment has been reduced by 90%. And similarly for other stations, more than 60%. And here down to the Vietnamese Mekong Delta, sediment loss has been reduced by 74%. And we could quantify that among these 74% sediment reduction, about 40% caused by 6 dams in the Lancang Cascade in China, of which 32% is due to Manwan and Dachusan Dam alone. So the final message is that, so although the transition discharge in the Mekong or in Vietnamese Mekong Delta has increased, but the water level has reduced because of sediment reduction causing riverbed in-season in the delta. So for studying the dam impacts on hydrology, we should not focus on water only. We should incorporating sediment and morphology to see the cumulative effects of dams. So that's all from my presentation. Thank you very much.
Thank you very much for that, Dean. So I think at this point, I see we've got 17 questions in the Q&A thread here. And so we are going to go ahead and move into our discussion. And I'm going to probably end up curating a few of these and perhaps combining some of them when they're asking similar questions to try and get through as many of them as possible. So I'm going to start things off with a question for Brian and perhaps Alan to chime in on. That's really a question about data accuracy. So we did have one attendee asking about, how do we verify the data? Is our data correct? Noting that there is a research team at Tsinghua University that had found some errors in the Mekong Dam Monitor. So, Brian, can you talk about the process that we have for sharing and demonstrating the accuracy of the data from the Mekong Dam Monitor?
Sure. Few points on that. We have a lot of users of the Mekong Dam Monitor. In fact, last year we had 20 million engagements on Facebook alone. So people talk to us quite often. They send us information, they send us observations, and when it's telling us something that is a little bit different from what our data is saying, we take it seriously. And in the case that was brought up in the questions from the Tsinghua University group, was great. It was a great set of information for us to look at our process, to refine our process. And what had happened was there was 3 points pointed out of about 20,000 points where the reservoir went up, and we said it went down to a certain degree. Importantly, overall, the trend that we outlined didn't change. It was a reservoir that was filling, and we showed that it was filling in kind of a jagged manner, but it was filling in a more linear manner. But this was great information. It was the first time we'd had actual reservoir level information out of China, and that helped us calibrate and helped us refine our methods. So it's about having a conversation to make these processes more refined. The virtual gauge process that we use has been verified against real observations. We take our remote sensing method and compare it to a reservoir that has actual observations to show that across a long time series, we're able to get within plus or minus 1 meter of accuracy on watching these reservoirs from space. But this is a remote sensing method. We're not there on the ground. We're using data, using analytical methods that are getting better and better to demonstrate. One other point I want to make is that Alan and I and the team, we take pride in using what we call corroborating methods to prove points. So Alan has the natural flow model. The Stimson team uses the virtual gauge process, and they both kind of tell you what the reservoirs are doing. They have corroborating stories. They basically tell the same story, and we realized that the remote sensing approach is new and novel, and that it's important to bring multiple methods that kind of tell the same story to show that there's something true being told. And a final point is that on the dam monitor, you can actually see the reservoirs. You can go in and look at actual satellite imagery to show what's happening to the reservoirs and the river levels with your own eyes. So that's just some commentary on that. Alan, do you have any points you want to make about collaboration and how we'd love to hear from more and how we address criticism that might come to us?
Well, you said it very well, that criticism is welcome. Criticism is how science advances, and collaboration and collaborating evidence and contradictory evidence is how we learn. We usually learn, I think all of us, from mistakes more than we learn from successes. I think that's true in all of our lives. And so what we're looking for is different sources of information that support the same answer, or if they're giving us different answers, why? And so we're constantly learning. And so we welcome anyone who has information, who has data, who is on the ground, to share with us what they know, what they're seeing, and either support what we're identifying or teach us why basically what we're observing needs some modification and correction, because we're advancing as a team and we want as many people to support our work as possible, because this is something that we're doing as a global community. So I'll stop there.
Thanks, Brian, and thanks, Alan. Our next question is from Alan Potkin at the Northern Illinois University, and I'm going to direct this one towards Andy, because I think you can share some insights from the story you worked on, Andy. But Alan's asked if you could elaborate on the connections between the flooded forest areas and fish in the Tonle Sap.
Sorry, you mean on the Ramsar site or the Tonle?
Sorry, I think he's just asking about flooded forests and why they're important. So, whether we're talking about flooded forest areas around the Tonle Sap or flooded forests elsewhere in the Mekong Basin.
Well, specifically for the Stung Treng Ramsar site flooded forest, the research that mentioned that Ian carried out before was across the border in Cone Falls, but has a very similar ecosystem to the Stung Treng Ramsar site. So I believe for that he actually looked into what the fish were ingesting and found that along with fishes actually using the fruits and leaves of the flooded forest tree species, that they're actually ingesting various parts of the tree, like the fruits and the leaves. So, not only is this habitat providing the nursery and spawning grounds, but it's also providing a food source for these particular species, like the cyprinid carps and the Paganthidae catfish. So it's through that looking into what they're eating, is that's how Ian's being able to understand how the relationship between the forest and the tree species with regards to food source.
Thanks for that, Andy. I'm going to take the next question. I'm probably going to try and bounce back and forth between data questions and broader questions. So this next question is a data interpretation question for Brian and Alan. And Andy Stone had asked about how to interpret the lower Mekong Basin flood pulse maps, pointing out that when we're looking at water coverage, do those maps show areas where the depth is similar to the past, or is it just showing a topographical coverage of an area that is covered in water? And can we talk a little bit about the difference or the correlation there?
I'll address that one a little bit and then pass it to Brian. Again, these are completely different sources of information. One of them is from satellites that observe microwaves, the wetness product, and that is observing how much water is on the surface or near the surface. So that is not measuring how much water is pooled on the surface, but it's measuring how wet the soil is. And then we have the other product, and I'm going to pass to Brian in just a second. He's bringing up examples. This example, these are telling you the percentage of the surface that is liquid water. So how much water is in the soil. And so that has nothing to do with height. It has nothing to do with how much water is actually pooled, but it's more of how much water is accumulating in the soil and then moving through the tributaries and through the rivers into the basin, into the lake, and then flowing out to the Mekong. So that's one source of information. And then we look at the SARS data, which is completely different source of information. It's how much water is actually pooled on the surface itself. And I'm going to turn it over to Brian or Reagan to speak to that.
Yeah, and this is just showing surface area. So the numbers that you see on the charts correspond to 1,000 square kilometers of flooded area. And the expansion is showing kind of a lower level of flooded area, 9,100 square kilometers of flooded area in early June 2022, and then a maximum of 18.2 thousand square kilometers of flooded area throughout the lower Mekong. We're not able to show depth with this. We would imagine that the higher, the wider the flood, the deeper it is throughout the floodplain, or at the lower portions of the floodplain. But one of the things I think is interesting is comparing what is flooded and what is not. And if you squint, and we don't have any big maps to zoom on, but what I love to do when these maps come in every 2 weeks is zoom in on the delta and see what parts are flooding compared to parts that weren't flooding previously. And that's showing areas that are being diked off, being secluded from flooding, or the opposite. Often now we're seeing areas where dikes and structures are being knocked down, where the floods can be reintroduced into the Mekong Delta to allow nature to do the work. But just to draw a point to Bean's presentation, as the river level is lowering due to sediment extraction upstream, it makes it harder and harder for the delta to flood. It actually also makes it harder and harder for the Tonle Sap to expand, right? Because you need higher levels of water. If the bed is lowering, more water is needed to do the same thing that it was doing previously. So the cumulative year-on-year impacts of that sediment reduction will through a natural process reduce the level of flooding that's happening on this map year on year, unless something changes.
Thank you for those clarifications and elaborations. This next question could likely be addressed to anybody in the panel, but I'm going to sort of direct it first towards Ellie, because I think it's responding to some comments that she made. But, a question is, if the Mekong is healthy in Cambodia, can we talk about some of the reasons that we hear bad news stories regularly, such as the Irrawaddy dolphin calves dying out or the dolphin population going into extinction? And how do we account for things that go beyond the expansion and the flood pulse to think about water quality?
Yeah, definitely. That was a really great question, and I appreciate it. The Mekong is still facing a lot of challenges. I think we've highlighted some of them, all related to flow and changes in the system. But we're still seeing recruitment and reproduction by a lot of these amazing species, and there's evidence of these fish still being present. I mean, we do have a population of freshwater dolphins. There's not very many left, but they do find refuge in the Mekong. We actually had a meeting with the World Wildlife Fund and experts on dolphin conservation just yesterday, where we could work together to collaborate and discuss some of the things that we're seeing happening in the system. And one of the main things that they were saying affects the dolphins is discarded fishing gear. So some of those mortalities that we see is maybe not a result of changes in flow or water quality, but more of kind of human impacts on the system. But we are excited to start and continue working with water quality measurements. Our group, in collaboration with Cambodian government organizations, we've opened a limnology lab. Just this week, we held our grand opening, and we've already collected and analyzed over 200 water samples from throughout the country. We have an amazing PhD student who's doing her work on water quality throughout the Tonle Sap Lake and river. And we're excited to have this opportunity to continue working on understanding water quality changes over the course of the next upcoming years, and really having long-term data sets that can inform us about the health of the river. So.
Thank you, Ellie. This next question is, I'm actually going to combine some questions that we have coming in from Lucas and Jerry about the water filling patterns this year for the Tonle Sap. So Lucas had asked, as we mentioned, this year's Tonle Sap was largely filled from the basin. We saw a lot of water coming from the basin back into the Mekong River. Do we expect this water pattern and weather pattern to be something that might repeat in the future? And then just as a follow-on to that, Jerry Flynn had asked if the Tonle Sap's reversal is seemingly playing a reduced role in this water flow in the basin and the basin's wetness, yet we're seeing more dive fishery catches this year. What are the expectations that we might have if this pattern continues for Cambodia's fisheries?
I think that's a huge question that's not easy to give a simple answer to. And it does come back to what Ellie just mentioned, that we need to understand the chemistry of the water coming into the Tonle Sap Lake from the basin, since it's more important than ever. What is the quality of that water, and how does that impact the growth of the fisheries, since less nutrients and less sediments are coming in from the reversal? So that is kind of one thought. I'm going to pass it off to others because I don't want to address this question alone.
Yeah. Thanks, Alan. I think I could comment a little bit more on kind of the connection between the water flow. We talk a lot in the past, we've talked a lot in Mekong about the connection between how much water is moving through the system. But as you mentioned, the quality of the water is connected to the quality of the fishery and the quality of the livelihoods of these people who are using this resource. And it's really relevant worldwide. So having these opportunities to go out and do more work on just the water quality and the amount of heavy metals or the amount of pollutants in the system is going to be really important moving forward. And we're well set up to continue doing that.
All right, thank you all. I'm going to ask another question from Jerry Flynn because I think it picks up on a really important thread that Ming Lee had raised, which is about the Stung Treng Dam. So Jerry has asked us, has there been any progress that we're aware of on the Royal Group Dam that was at least until recently under feasibility study on the mainstream at Stung Treng? So Ming Lee, do you have any updates on that or anything you've heard?
I don't have any updates on that from my end, but I do know from my visits to the area that when the dam was initially proposed, they were extremely worried about that. So, for example, the community in Papua and Aceh were very worried about what were the implications that this dam would be for their livelihoods that were also based around ecotourism that people would come for to look at the Irrawaddy dolphin. I think where these dams are involved, there are always going to be these concerns. So I think it's going to be very important to look at the any contradictions between the commitment that the Cambodian government in terms of having a moratorium on Mekong dams. So trying to get more information on what's happening in the surface. Yeah, I think it's really important that we continue to pay attention to this situation. So I'm not sure, for example, what form this dam is going to look like when it's revived. So yeah, if anyone has any more information on this, I'd be happy to hear it.
Well, I know Brian was just there in December and had some conversations on this. So Brian, do you have any further insights?
Well, I mean, for those of you who watch our work, you probably know I'm a person who watches the river like all the time. And I wake up in the morning and I write people and say, how was yesterday's fish catch? And, I try to keep in tune with what's happening in the basin from far away. And I go every once in a while as well. When there's any talk about one of the far downstream dams, it's something, it like literally keeps me up at night for a long time. So when the rumors of the Stung Treng Dam were, being resurrected, hit last year, it was obviously concerning for many people because those large dams on the mainstream of the Mekong will wipe out the dolphin population. They're going to wipe out the flooded forest that Andy showed us pictures of. And I mean, these are, in simple terms, we call them the game over dams for the mightiness of the Mekong. So there has been no actual evidence other than the feasibility study done by the Royal Group on the Stung Treng Dam, that anything else is moving forward with this dam. And I've talked to numerous high-level officials in Cambodia who all say the same thing, that the commitments made at COP26 by Minister Saisamal are real commitments, and Cambodia is committed to this. We look back at just a few weeks ago, Prime Minister Hun Sen made a huge commitment to protect dolphins around the Kampi Pool, which Ellie was describing. And I think that only furthers and shows the commitment that the Cambodian government has to not building big dams on the mainstream of the Mekong. So we should hold those commitments at face value, but watch the situation very closely. I'm also very concerned about the Phu Noi Dam north upstream of the flooded forest in Laos, which has some talk about it moving forward, as well as the Sekong A Dam, which is a very small dam on an undammed tributary of the Mekong far downstream. That is another one of these game over dams, and it's about 50% complete. But no one's talking about it in the media except for Jerry Flynn wrote a really good article about it. And much more needs to be done to gather information and to hold the developers accountable to the serious impacts that particular dam is going to deliver to the downstream.
Thanks for those updates, Brian. I'm cognizant that we are a little over time. I do want to ask one final question, getting at some of the things that Bean had highlighted in terms of sediment changes. We have one question from Carlos Yumali about what does the lower sediment load trend mean for the Mekong Delta? Does it forecast a shrinking of the Delta in the future? And what are some of the implications for the many millions of people that live there?
Yes, thank you very much for your question. So sediment very important for the Mekong Delta, not only thinking on the morphology of the Delta. And of course, one study by professor in US, they also forecast that with the ongoing reduction in the sediment loss in the Mekong, the Delta will be shrinking, not only shrinking, but sinking also. And also sediment loss also very important for agriculture, for fishery, small fishery in the floodplains of the Mekong Delta also.
And just to add on to that, the sediment is the basic building block of a delta. So sediments that cast across a floodplain, the Mekong Delta is a floodplain. We've shown you many maps that show the delta flooding. When those floods happen, sediment is deposited, and that's what builds the delta out into the ocean. The Mekong Delta itself is relatively young in terms of a piece of land. It's like 3,000 years old. And all that land was built out over that 3,000 year period. Now the delta is losing football fields of land each day due to sea level rise, due to the sinking that he's talking about. Bean is talking about, that's from groundwater extraction, as well as the lack of sediments being cast across the delta for a variety of reasons. There's a question about, do you see any positive future for the area and its people? Well, the people have to work on the future. If floods are going to continue to do their good work, well, the people have to work with nature to keep the floods coming, to keep the sediment coming. There are ways to reconfigure dams, there are ways to operate existing dams, and there are ways to site new dams and not build new dams that can allow floods to happen, that can allow the natural ecological processes of the Mekong to happen. But we got to work together on it. And I just want to note that the group that we've gathered here for this discussion, we've got some real champions of Mekong conservation with us. And I want to thank you all for joining us tonight. Just a personal thank you from me and from Alan for a great discussion, but I'll turn it back to Courtney to wrap us up.
Yeah, so, with that said, I just want to thank everyone for joining. I think it's been a good discussion. I do see too that we have 13 questions, many of which are still very good questions in the queue. So what I can do is share those questions with our panelists, because I think they can prompt very useful follow-up discussion. So for those who have asked questions that didn't get answered, I'm happy to share your contact info with our panelists and see if we can get you some answers to those questions. But for everything else, I hope you'll continue to engage with us for future events. We do these seasonally, and we also have ongoing opportunities for conversation on the Mekong Dam Monitor's Facebook page and over social media. So please do feel free to stay engaged and ask these questions and keep the conversation conversation going. So thank you all for joining. Thank you all for the discussion, and we look forward to seeing you at the next seasonal update.